Hello everyone. In this video we're going to be solving an equation with exponents. If you like this video, please comment, subscribe and hit the bell button for notifications. If you don't like the video, let me know why in the comment section down below. I appreciate all kinds of feedback. Thank you for watching. Let's get started. Now, we do have an equation with 3 to the power x plus 2 divided by 3x minus 4 minus 7 equals 2 times 3 to the power 5x minus 10 divided by 3x minus 4. So this is an exponential equation. But one thing about this problem is that the exponents are different, right? If we had the same exponent, we could put it all together and just solve for it and, log both sides, so on and so forth. I mean, you could try to log both sides, but you're going to run into some complications. But there's something that makes this problem really interesting, which I'll show you now in a little bit. And then we're going to go ahead and solve it. Okay, now, what is that observation that we need to make? If you look at the exponents, one of them is x plus 2 over 3x minus 4. And the other exponent is 5x minus 10 over 3x minus 4. Now, you might be thinking, okay, if we had 5x plus 10, that would be nice because then we could say that, okay, one of the exponents is 5 times the other. So you would get something like, let's say 3 to the power a and then 3 to the power 5a or something like that. It would be quintic, but it would still be okay. But we don't even have that. But there's something that makes this problem really unique. That's why I picked this problem for you guys. And that is only clear if you go ahead and add these two fractions. What happens if I go ahead and add them? Well, since they already have a common denominator, I'm just going to add the numerators. X plus 5x is 6x, and then 2 minus 10 is going to give me negative 8 divided by 3x minus 4. Do you see what I see? Okay, awesome. Look at that. The numerator is divisible by the denominator. Why? Because you can basically factor out a 2 here, and then you should be getting 3x minus 4, and then divided by 3x minus 4, and this is going to give you a 2 when you simplify it. Awesome. So these two cancel out, leaving us with 2. But one question we need to ask, is it okay to simplify? Because what if 3x minus 4 is equal to 0, right? Then you can't do this, obviously. So, but if you look at the original problem, 3x minus 4 should never equal 0, right? Because then we have a problem, right? Okay, so first and foremost, we have to establish the fact that 3x minus 4 can never be 0, so what we did is okay. Well, this is nice because the sum of the two exponents is equal to 2. But what is that supposed to mean though, right? Well, it has a good meaning, which is, I'll explain that right now, okay? So since x plus 2 over 3x minus 4 plus 5x minus 10 divided by 3x minus 4 is equal to 2. Now, in my equation, I have both of these exponents. So if I call one of them, let's say a, right? So let's call this one a. Let's call this one a. Then the other exponent automatically going to be what? 2 minus a, right? So this is going to be 2 minus a. Nice. So this allows us basically to use substitution for this problem. Let's see how that proceeds, okay? So what I have is 3 to the power a. So I'm going to start off with that. We have 3 to the power a, okay? And then minus 7, right? Minus 7. And that is equal to 2 times 3 to the power the other expression. So I started off with this, right? Actually, nope, that's not right. I messed up. This is supposed to be, because we get the x plus 2 first. So that's 3 to the power 2 minus a, right? So that's 3 to the power 2 minus a. And this is going to be 3 to the power a. There we go. Okay, so what I did was basically I called the second one a. So this should be basically a, right? And this should be the 2 minus a, the second one. Okay? Awesome. So now, from this point on, this problem should be fairly easy to solve, don't you think? But we still have to do a couple things here. Let's go ahead and do them. First of all, notice that we can write this as 9 over 3 to the power a minus 7, which is equal to 2 times 3 to the power a. Now, at this point, you know that 3 to the power a can never equal 0, right? I mean, that's impossible unless a is approaching infinity, which is going to be a limit problem. I mean, negative infinity, obviously. So we can multiply everything by 3 to the power a, which gives us 9 minus 7 times 3 to the power a, which is equal to 2 times 3 to the power a multiplied by itself is going to be 3 to the power 2a. Nice. Now, what does this mean? This means that you have the following. 2 times 3 to the power a, and I can write it as 3 to the power a squared, can't I? Add the 7 times 3 to the power a, and then I have to subtract the 9 because I'm getting everything on the right-hand side, correct? Okay, and this should all equal 0. Nice. Now, what does this look like? This looks like a quadratic equation. If you make the substitution, which is what? If you call, hey, okay, 3 to the power a, let it equal y. Awesome. Then we have a quadratic y because this y is y. So 2y squared plus 7y minus 9 is equal to 0. Awesome. We know that 3 to the power a is equal to y, and we're going to solve for y. One solution is positive, one solution is negative. You can totally discard the negative solution. And how do I know that? From Vieta's formulas. Remember, we had a video on Vieta's formulas with examples. Hopefully, you guys got to watch that. And it's really fun topic, and time to time I'll mention that and maybe solve more problems on Vieta. But in this case, we can tell the product is negative, the sum is negative. Obviously, what? That means both solutions are negative? Wow, that's kind of interesting. I never thought about that. But anyways, let's go ahead and proceed and see what this gives us. Okay, so, and let's make sure that we didn't make any mistakes because this kind of looks like, what? We don't have any solutions? It's impossible. Well, it's sometimes possible, of course. But anyway, so basically in the original problem, we have 3 to the power 2 minus a minus 7 is equal to 2 times 3 to the power a because that's what I called a. Okay, so that should be good. I mean, it looks good to me. So 9 over 3 to the power, I'm just checking my work to make sure that we have good solutions. 3 to a, 3 to the a, and then 3 to the power a. Okay, so far so good. Now, so what are we going to do now? Well, we're going to solve for y. Let's go ahead and do that. Y is going to be negative b plus minus the square root of b squared minus 4ac. So it's going to be 4 times 2 times negative 9. Okay. So that's going to be, okay, divided by, b squared minus 4ac. So it's going to be positive. Oh, I was wrong when I said that both solutions are negative because what happens here is one of the solutions must be positive, right? Because the product is negative, which means we have a positive and a negative solution. So we're going to go with the positive one. But let's go ahead and simplify this all the way through. So let's see what that looks like. Okay. So this is going to give me 4 times 2 times 8, which is 72. 72 plus 49 is equal to 121. Wow, that's unbelievable, right? That's a perfect square. Nice. Okay, of course, this has rational solutions, obviously. So it's going to be like negative 7 minus 11 over 4 and negative 7 plus 11 over 4. And this is going to give us negative 9 halves, which is negative. So we're not going to be able to use that because 3 to the power a can never be negative. Impossible. Think about the graph of it, right? It has an asymptote at y equals 0, so on and so forth. But this will be 1. Okay, well, we could have told that it's 1, right? Because if you look at the coefficients, the sum is 1. So we could have figured it out anyways without the formula. But anyways, so y equals 1 is valid, right? And that is equal to 3 to the power a. From here, we get a equals 0 because 3 to the power 0 is 1. But that's not the answer because we're looking for what? We're looking for x. And what did we call a? 5x minus 10 divided by 3x minus 4. 5x minus 10 divided by 3x minus 4 is equal to a. And we know that a is equal to 0. Which means 5x minus 10 is equal to 0, obviously, because denominator cannot be 0, but the numerator must be 0, and x equals 2 is going to be the only solution to this problem. Okay? And I think this is a good place to stop. Thank you for watching. I'll see you in the next video tomorrow. Until then, be safe and take care. Bye-bye.